Hello everybody, I'm Storm here, and welcome back to Kerbal Space Program. In the last episode, we ran a mission to Kerbin's North Pole to gather a little extra science, which got us some additional parts that we then used to design and fly a new vehicle to land on Minmus with a redesigned lander, which proved to be more successful than the one that we used on the moon, but still had some problems, namely that using those 1.25 meter parts necessitated making the lander fairly tall, which meant it was fairly top heavy, and when we landed on a sloped surface, that even though the slope was fairly slight, it caused the lander to want to tip over, which forced me to have to lift back off of the surface and find another landing zone, which burned a lot of fuel unnecessarily, and so just wasn't great, even though thankfully I had over-designed the vehicle and therefore had enough delta V on the lander when it got in there to do what needed to be done and get the crew home safe. So we got back, big pile of science, spent it on some new tech, and now we're ready to move on to the next thing, which we're going to be continuing to work on getting science from the moon and Minmus. We're going to be designing a new lander, of course, because, that one just didn't work. And one of the things that I'm going to want to do is actually going to necessitate, at least I think it's going to necessitate, setting up a communications satellite network. So that is going to actually be the thing that we're going to work on right now, is getting some communication satellites in Kerbin orbit that can basically cover the entire Kerbin sphere of influence for communications, and therefore relay signals from anywhere else in the system, because I do have the Breaking Ground expansion, so we're going to be doing some actual permanently installed experiments on the moon's surface and on Minmus' surface as well to gather more science. So first thing we're going to need to do is we're going to need to design a lifter to get fairly decent sized payloads into Kerbin orbit that we can reuse fairly regularly. And it is a bit flexible so that we can, expand it with some boosters if we need to, or, just use a simpler setup. So, I think the first thing we're going to do is put together an upper stage fuel tank. This is what we're going to actually start with, is the root part. And let's see, which one do I want to use? That's probably going to be too much. I don't know what the difference is between these two. This is actually lighter. 1.278 tons. 1.8 tons. It comes with 200 units of monopropellant. Oh. Don't need that. No, not going to need that for this. So we're going to go with this one that is lighter. And let's see. Since this is going to be liquid fuel oxidizer, I don't think... Or do I want to make this a... Do I want to make this a cryogenic tank? Let's see. The cryogenic tanks are also lighter. LH2 and Ox. That gives a delta V of almost 4,000 meters per second. That's pretty ridiculous. You know what? We're going to go with it. We're going to go with a cryogenic upper stage, using the CE-2X Ulysses rocket engine. So that should be a good start. And then we're going to need our 2.5 meter decoupler. And then we're going to want a tall center fuel tank to be the primary core stage. And the engine we're going to want on this thing, I think, is going to be the Maverick from KW Rocketry. It's a pretty decent engine, and it's pretty good when you don't have to lift really heavy payloads. We'll have to see ultimately what the thrust to weight is once we have a payload on this thing. And the other thing we're going to do is we're going to throw some fins on it. For stability. Alright. And then I'm going to go ahead and save this as a subassembly. And we're going to call this the Gladius lifter. Alright, so that's going to be just your pretty basic two-stage rocket that should get most payloads to orbit. Now, we are going to design a second version of this that is going to have, let's see, we're going to want some significant ejection force, so I'm going to want this one, the hydraulic detachment manifold. There we are. And then we're going to throw these tanks. And then they are also going to use, I think, the Maverick engines. Yes. Alright, so those 4 fire. And then we do the radial decoupling. This also is going to need this guy. This little solid motor that will push. Let's see, is that centered? Yeah, it is. Okay, they will push those big tanks away from the center tank when they decouple, just so we don't have any unfortunate incidents where the aerodynamic forces push those side boosters, the side tanks, into the center tank or into the engine or anything like that. Which has happened before. I want to make sure that those go there. Okay. Alright, so that should be another fairly basic design. And what we're going to do is go ahead and save that one as a subassembly as well. And we're going to call this the Gladius Heavy. Save it. Okay. Alright, so with that, we're going to actually design a payload that we're going to try and put in orbit. I want to try and do the rocket design kind of in this method, though it isn't always going to work that way. But I'm going to give it a try. Alright, so for this particular mission, we are going to need it to be manned. So we're going to need a pilot on board who can fly the ship, because, I mean, I think there is some ground control, but I'd rather not rely on it. So I think I'm just going to go ahead and use the Mark I lander can as the cockpit for the vehicle. we are going to need a heat shield. There's going to be... It doesn't need to be that big, but it does need to be somewhat larger. Yes, because if you put a... excuse me. Sorry. If you put a 1.25 meter on there, it's not big enough to cover the entire capsule there. So I'm going to need the 1.875 meter. Yep, that should put everything behind the heat shield. Alright, you're not running any science payload, so we're not worried about that, but we are going to need some parachutes. 2 parachutes should be fine. We're going to need some batteries, I'm thinking, and some method of generating power. Those are a bit too large. Come on. There we are. Those ought to work. Alright. Good. Now, I want to bring 4 satellites here on this particular flight. So, for coupling, small stack decoupler like that. And we need a basic probe core. There we are. It's going to need some battery. Yep. It's going to need some solar panels. I think we're going to go with the 1x6s. Flip them around like that. 4 of them. And then it's going to need a communications antenna. At least 1. Now, if I want this to cover the entire Kerbal SOI, we're going to need about 360 megameters of coverage. And we do have the level 3 surface station, because we're not playing in career. So, I also need something that's relatively compact. I like these. So this should have a 447 megameter range. 22.4 gigameters. Yeah, that's a bit larger than I would like. 354 megameters. Now, 1.12 gigameters. Again, too large for this vehicle. Alright, so I think that this guy is it. I'm going to put a couple of them on there. Alright. And that should be all we need for the satellites. So let me go ahead and do another subassembly. This is going to be a... let's call it a small ComSat. And then I'm just going to stack a bunch. There. We can start with 4. Alright, now we're going to need to put this whole thing in a fairing. So I'm going to need a fairing. Let's see. KW fairing base. That ought to work. Actually, we're going to need a decoupler first. There we go. That should make hooking this up a bit simpler. There we go. This is going to need to be 2.5 meter diameter. Looks good. And then we're going to need to actually throw the fairing on here. Conic. Procedural fairing, recolorable. Yeah, that works. Let's see. Do we want to give it a specific color? Gold. I kind of like that. Black and white checker pattern. Alright. So, that's our payload right there. Now, Now, the thing is that we need to reroute select the new part as a route, which is going to be... There we go. Nope. Alright, something goofy happened there. Oh, it shows the actual... This thing is the route. Well, that's goofy. So I gotta put this on a new route. There we go. And then I need to reroute it again. There we go. That'll fix that. Alright then, I guess it doesn't like being rerouted. That's okay. We'll just... No, I don't want to move that. Just keep that fairing off for the moment. Alright, so I'm thinking we're going to try this with just the standard lifter. I'm going to want to put this in a polar orbit, so it is going to need some extra thrust. Alright, we need to make sure that this is staged right. Alright, and then this guy is next. And then that engine fires. See, 2,000 meters per second at delta V, 3,000 meters per second at delta V. It might be enough. And then we actually probably want to have the fairing go. And then we're going to want that top one to go. And then this one to go. And then that one to go there. Before finally detaching the whole thing. Alright. I think this will work. I'm a tad worried about the amount of delta V we have if we're going to try and put this in a polar orbit. But, you know what? We'll see. If we can't put the satellites in as high an orbit as I'd like, then that's just the way it's going to be. Alright, so who's going to fly it? I guess Jeb can fly it. Let's go ahead and launch it. Now, there are a couple ways of doing this. You can put the satellites in geosynchronous or Kerbal synchronous orbit. Or you can create a constellation of lower orbiting satellites that just provide the coverage you need. And those did not go in the right spot. There we go. And so that's what I'm going for. A larger constellation of lower altitude satellites. Should get the job done. Alright, so let's go ahead and fire this thing off. Alright. Now I'm actually going to want this on orbit because I need to get that to get onto the north line because I got to cancel out the speed of the rotation of the planet. We can throttle down the main engine so we're not incurring too much drag. I think we're going to start to throttle back up again. Probably throttle it down just a bit. Almost got that prograde where I want it. There we are. Throttle it back down again because we're getting a little bit too fast. Alright, we're at 90,000 meters for apoapsis. That should be good enough. And actually I'll be able to ditch those fairings sooner. Let's go ahead and set up our maneuver node for the circularization burn. (1500 meters per second). There's not near that much in there, so all right, ditch the fairings. All right, let's have Jeb get this thing in position. (32 seconds is the burn time. Yeah, this thing does not have very good reaction wheels, so maneuvering without the engines is going to be troublesome. All right, I'm actually going to go ahead and burn a little bit early. Because the next engine that's going to fire is not as strong as this one. Well, it actually was a bit stronger than I anticipated. Okay. Good. Alright, we're going to hold prograde. I want to get the apoapsis height to about 300,000 meters. Good enough. We have 1,800 meters per second in the tank. Alright, next maneuver is going to be the circularize. So right about there. And that's going to use up 137 meters per second. That should be fine. Alright, so let's go ahead and warp. Let's see, we want to warp right about there. I want to hold the node. It's going to be about a 3-second burn at maximum. Maximum thrust. You got this under control there, Jeb? Yeah, he's got it. Okay. We're definitely not going to give it full throttle. Well, maybe we will. Let's see, that should be a burn at like, what, 1.5 seconds? That's 5, 4, 3, 2, burn, and kill it. Close enough. Good. Alright, so I want to orient to normal to the orbit. Because if I fire this thing prograde or retrograde, it's going to either raise or lower the orbit. If I fire radially in or radial out, it's also going to affect the orbital altitude. But normal, either the normal directions, shouldn't affect the orbital altitude. It'll affect the inclination a little bit, but shouldn't have too much of an effect on it. Alright, so let's get these solar panels extended. Let's get those antennas extended. And then let's release. There we are. Perfect. Alright, let's reorient prograde again. And let's get up to the next altitude that we are going to want to be at. Which I want to bump this up to about 350,000. 350,000 meters. That's close enough. All right. And I'm just going to kind of eyeball a lot of this. We're going to warp over to the apoapsis. All right. These orbits don't need to be precise. They just need to not bump into each other. That's the important part. I don't want my satellites smashing into each other and, you know, getting us on the way to Kessler syndrome. All right, there we go. Go normal. Extend all of the solar panels. Extend the antenna. Now I'm probably only going to do one set of these for now. I actually might do several more sets of these satellites, but probably off screen, because I mean, once we've flown this mission once, we can fly. I can fly several more of them just to get the additional coverage. All right, make sure this is the right separator. It is, and go. All right then. Next. All right, so 400,000 meters is the next altitude. Okay. Warp over to the apoapsis. All right, orient prograde. Let's see, time to apoapsis is what, 30 seconds? All right, let's go ahead and fire the engine. Give it just a little bit of gas. There we go. Periapsis height is up to 400,000 meters. Good. Normal. Now, I could have put these solar panels on action groups, which probably would have been a better idea. So then I could just press a single key and extend everything. All right, you guys are where you need to be, and that is the right separator. Let it go. All right. And one more. Bump us up to 450,000 meters for the final release, which is going to be over there. Warp over there. Oh, actually, hold on. That was wrong. We're going to warp there. Yes. Misjudged which direction we were going. Alright, so if I turn on all of the connections, you can see everything. Alright. Let's bump that altitude up there. Okay. And then we orient to the normal and release this last satellite. And then we bring Jeb home. And then we begin working on the design for the next moon mission. Alright, so we need to get the actual antennas extended. Extend the antenna. Extend the antenna. And make sure that's the right separator before pressing the button. You don't want any mishaps like we had last episode. Alright, there we go. So, we just now need to orient retrograde and then set us up to come home. Alright, I'm going to drop that periapsis height to probably about 20,000 meters. Actually, that's going to bring us in over land. Can I... Oh, actually, we're going to land over there because Kerbin's going to rotate. Yeah, we'll put it in the middle of the ocean. That's fine. Alright then. Let's bring us around. Alright, I'm going to swing around normal again. And that's going to be that separator right there. And kick us off. And this should be stable because that heat shield should be heavy enough to keep us oriented in the right direction. So I'm actually going to disable SAS and test that theory. Alright, so what is that going to do? Are we going to get any nice explosions? Maybe not. There's a lot of fairly solid parts on that. So it's not like it's got any solar panels or anything else like that on it. Alright, I think I'm just going to go ahead and do 4 times warp on this. We should be alright. Yep, there we go. I'm going to get that speed below about 280 meters per second. And then we can get those chutes out. Yep, deployed, and then we'll keep the heat shield. But I'm going to keep the time acceleration on because I just want to kind of get through this. This is basically just a utility mission. It isn't one of the science missions. But it's something that needs to get done. Alright. Recover the vessel. Alright, next. Done. So, the next thing is we need to set up for a new moon mission. We need to design a new lander. One that is... Oh, I kept that as entitled spacecraft. Ah, crud. Should have given that a name. Alright, but we're going to go ahead. We're going to start over new. Okay, so for this one, we're going to be doing a 2.5 meter diameter lander. So we have the Mark 1-3 command pod. Okay. It's going to need a science payload. And what I'm thinking of doing, and hopefully this won't give us any problems, is to use this 2.5 meter service bay for our experiments. The problem with this is a very lightweight piece of equipment, which may make it unstable during re-entry. You'd think I'd learned my lesson on that, but we're going to give it a try. I'm going to hopefully try and put enough weight on the bottom of it that it should be okay. Alright, and I should actually be able to put this guy like right inside. There you go. There it is. That's the direction I wanted to rotate them. Alright, so the goo stuff. Thermometers. Barometers. All the standard gear. Okay, we're also going to want to bring some battery packs. And let's see, some life support, I'm thinking. We're going to put the life support in the service module. We'll put some of these mini packs in here. How many days does that give me with a 3-man crew? 12 days. That should be enough, honestly. Okay, the next thing we're going to need is we are going to need cargo. No, that one's a bit too large. This one should be fine. I'm actually only put one in there. How much does it weigh? 0.05 tons. Yeah, that won't cause a problem. Alright, so it has an inventory of 3 spaces. So we're going to want to bring a Probodyne experiment control system. There's something goofy going on with the icons here, because I've actually, played around with these a little bit. I don't know why that's not working. It's there, but the icon's just broken for some reason. The GOB ED monitor, okay. And we're going to need the photovoltaic panel. We aren't going to need the weather analyzer because there's no weather on the moon. Alright. That should be everything we need in our service bay. Now, what is the heaviest heat shield that I can mount? See, there's the procedural heat shield, but I don't know. No. How heavy is a 2.5 meter, 1.3 tons? Do I have anything bigger than 2.5 meters? No, I do not. could double heat shield. Mass 1 ton. 1.3 tons. We'll see if the 1.3 tons is enough. Alright, so we're going to need the parachute cone. And I'm thinking we're going to go with the retractable 1x6 solar panels here. Just 2 of them. Set them up for an action group. I like those because they're retractable, even though they are a little bit heavier. In fact, I can probably take advantage of the fact that they are a little bit heavier by mounting them a little bit lower on the service bay. See if we can't move some mass down that way. I don't think center of lift makes any sense for this. There we are. $3.75? No. 2.5 meter decoupler. Okay. Now, we need the fuel tank, engine, and landing apparatus that is going to get us down to the surface. And I really want to use this engine. That's a monopropellant engine, so I need a monopropellant tank. Does this have monopropellant as an option? No. That's a monopropellant tank, but it's too small. This does not have a monopropellant option. I might need to use a procedural tank. Can I use a procedural tank that has 2.5 meter diameter and has monopropellant? Something goofy is going on with that. It doesn't look like it. Procedural liquid tank. Procedural RCS tank. There we go. A procedural monopropellant tank. Specifically. Perfect. I need you to be 2.5 meters. I need you to be 1 meter tall. Alright. Let's see. Plain white? Or we go with the stripes? It shouldn't be that hard to decide what texture you want to use. We'll go with that. Why not? Alright, let's go ahead and put the engine on there, and let's see what we've got as far as delta V. 1,398 meters per second of delta V. That is not a lot. But if I remember correctly, this tank, this engine has the option to put some extra fuel tanks on there for 1,500 meters per second at delta V. I think that should be enough. What is the thrust to weight ratio on the moon? 5.05. Way more than we need. Alright. Good. Now, we need landing legs. There are these, the landing struts. And that should be acceptable. But I was also looking at these, the landing stabilizers. A large stabilizer, great for landing your payload or base component when you can't find a level place to land. That was the problem we had last time. And if I extend those, they extend to a very wide base. The problem is that there's not a lot of clearance between the pad and the engine. Unless I can lower them just a little bit. It's going to be... Oh, I could... See, if I lower them a little bit, they get on a bit of a different angle, and that gets some additional clearance. But they're going to be sticking out into the airstream a little bit when you launch. Well, I'm going to try and launch with it. And if they tear off due to, well, like heating during liftoff, then we'll have to abort and try again. And then let's go ahead and put another decoupler here. There we are. Now, the other thing is that our Kerbals are going to have to be able to get to the service bay. And what I think I'm going to want to put on here, because I think we unlocked it, is these, the mobility enhancers. That should help the Kerbals grip the sides there. Except we don't need all four, we just need one. Primarily the side where we're going to try and access that cargo bay there. Or cargo container. Hopefully that's close enough, because we can't really, well... I don't necessarily want to mount it there. Alright, we'll give it a shot. Surface mounted Omni lights. Do I need lights? Nah. Demolition charges. I don't know what I'm going to use those for, if anything. Alright, I'm going to go for the Gladius Heavy. Try and launch this beast. Okay. Let's get all the staging set up. Look at my Delta V's and see if I need to make any adjustments. No, we need that one to go. And then we need that engine. There we are. And then that decoupler. And then that engine. What engine is this? What engine is this? Oh, that's the main center engine. Yeah, you should be firing, actually, as part of that group there. Okay. So, what are we looking at? First stage, 1900 delta V. Then 2000 in this one. We have 1900 in the 4 boosters. And then another 2000 there. And then another 981 there. That's not going to be enough. That is definitely not going to be enough. So I'm actually going to swap out that tank for a slightly larger tank. For that tank there. And we're going to make sure that that is liquid hydrogen and oxidizer for the cryogenic engine. Alright, so now that is 1752 delta V on the upper stage. Alright, and now we're going to call this Gladius 1. Save. And we're going to need the launch support struts. There we are. Oh, there is one. There is one other thing that I am going to want to do. And it may necessitate changing this parachute up. So I completely forgot about it. That's fine. No, I don't want to put that there. 3 parachutes should be okay. Oriented like that. Yeah, that should be fine. What we're going to want is a small fairing here. With a little decoupler, we're basically going to carry a little communication satellite with us that we're going to deploy in moon orbit. Actually, I'll just use that same ComSat, right? We already have it. Yeah, there you go. Let's bring one of those along with us. And deploy that in moon orbit. And we bring one of those along every time we fly to the moon, we can begin establishing a fairly decent ad hoc comm network in moon orbit. There we go. And that fairing is going to deploy at some point. We'll probably have to manually what are you doing there? I don't know. Okay. Save that again. Alright, I think we're good. Let's go ahead and launch it. Oh, who do I have as the crew? As long as I have a pilot, a scientist, and an engineer, I'm okay. If I don't, I'm going to have to revert. Pilot, engineer, scientist. Jeb, Bill, and Bob. Alright. We'll go with them. Even though Jeb just flew a mission. That's fine. It was a fairly sedate mission. You guys need to be on that stage. There you go. Okay. Let's see how it goes. Let's start nudging it over just a little bit. And throttle back. Avoid fighting too much drag. Alright, throttle it up. We're starting to get a little bit too much speed. We're going to burn these guys off, and then I'm going to let it coast for a little bit. Oh. It's starting to destabilize. Alright, there go the boosters. Alright, that should be good. Actually, I'm going to go ahead and burn some fuel here. Push that to about... Oh, there should be fine. Okay, add our maneuver. We'll finish off the rest of that burn. Wow, this has way more energy in it than I anticipated. Probably didn't really need that extended tank on the upper stage. When I get some better like flight computers and stuff that actually have the 2.5 meter diameter, I'll be able to turn some of these upper stages into actually like communication satellites and things. Be able to put some antennas and stuff and solar panels on them so that I can just ditch them in orbit and then they can stay there as a relay. Oh, we need to deploy our solar panels. And I also need to ditch those fairings. There they go. Alright, we're going to burn at about 16 seconds. T-minus. And I'm actually going to do is I am not going to push this all the way into orbit. I'm going to get close. So I'm actually going to start the burn a little bit sooner. I'm going to get it to the point where we are still suborbital. Right about there is fine. Ditch it. Engage the engine. Complete the rest of that burn. Good. So then that part will fall back to Kerbin. And then we can proceed on. Alright, so where is the moon? There it is. Alright, we're going to go ahead and set up for it as usual. Can I get a tad closer? Alright, that's not a free return trajectory, but it is fairly efficient. So we're going to risk it. Alright, let's warp to the maneuver. It's going to be a 49-second burn, which means we're going to burn for 24.5 seconds. Warp there. Oh, warped a little bit too close, but it should be alright. Oh. Accidentally bumped the button there. Hopefully that won't affect things. Periamps is 144,000 meters. That's actually going to be perfect. Warp to our encounter. All right. Whoa, 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 whoa. Oh, jeez. Overshot. But we're all right. It's not an ideal orbit to deploy this satellite in there but you know what? That's what we're going to do. Alright, we're going to do the same thing where I point normal just to kind of get it out of the path that I'm going to be burning in. Alright, so there is the one we want to decouple there. Okay. Alright, let's go ahead and lower our periapsis. And prepare to get us into a spot where we can land. Ooh. I don't want to have a orbit that intersects the ground. Just as a matter of principle. Yeah, there we go. Alright, I'm going to tell it to warp there. Okay, let's go retrograde. And I'm really not worried about exactly where I put down. Anywhere is going to be fine. Basically anywhere other than where we first landed. Guess there should be a marker for that. So I did plant a flag. Oh well. Let's go ahead and burn off the fuel in this tank. There it is. There's the first one landing. So we don't want to end up in the crater. Okay. Ditch it. Why aren't my gear going down? All right. Fine, we'll do it manually. All right. Now here's where I take over manual control. We're at 15,000 meters. We're at 135 meters per second. I'm going to give it a little bit of juice. So I don't want to arrest whatever lateral movement we have here. We'll switch to surface. All right, gonna let it fall for a little bit here. All right, there's the impacts. There's our shadow. All right, want to burn off the speed. Burn off the speed. Oh, oh. Keep the lateral velocities low. I want to get this below 5 meters per second. Get it below 5 meters per second. And get ready to cut thrusts. Now. There we are. And if I disable SAS, we are stable on the ground, even though we are on a little bit of a slope. Excellent. Hopefully 1,000 meters per second is enough to get back home. Alright, temperature scan. Mystery goo observation. Material study. Crew report. Atmospheric pressure scan, and then EVA report is going to be, well, Bill Kerman's going to be getting out first, the engineer. EVA report, yep, there we go. I can take a surface sample from here. You know, let's go ahead and do that. Take the data, store the experiments. All right, so, oh, I put one of the solar panels like directly underneath of where. I'm going to need to reboard and retract that solar panel. I didn't think about that. That's alright. That's why I like the retractable solar panels. And get them out of the way if I need to. Okay, Bill. Let's let go. Now, from what I understand, is that if the engineer is the one that sets up some of this equipment, it actually works better. In particular, the solar panels. Okay, so if we grab the photovoltaic panel and put it in his inventory, I'm going to go find a spot where we can set this up. Let's see. That's good spot as any. Alright, there we are. So it's producing 4 power units. All right. Let's get Bill back on board. And then we're going to grab Bob to set up the rest of the gear because he's a scientist. Ooh. That was odd. Alright, so the experiment control station is going to be first. I'll get that over here and placed close to the solar panels. Com first hop distance, 11.3 million meters. Okay, so yeah, it is going to need probably that relay to be able to transmit data. Alright, and then let's place this monitor here, because this is the actual experiment. Science, 1.125 points per hour. 100% rate. Connected. Excellent. Now, if I show the entire network, because they're probably actually relaying through our ship. Because our ship has a built-in antenna, so that should be alright. Hopefully. Let's get Bob back aboard. And then Jeb, we're going to have him EVA to plant the requisite flag. This is going to be our second moon landing. Black text. A third time's a charm. Alright. We finally got a lander that doesn't try to destroy itself. Hopefully it has enough fuel to get home. That's the one concern I have. Is there enough gas in that tank to get this thing out of here? Alright, let's close. Let's see. We are going to want to head 90 degrees. I'm going to try and not even worry about going into orbit. I just want to go straight to escape and hope that works. Whoop, whoop. I guess these stabilizers aren't automatically assigned to the gear button. Okay, well, that's something I can do in the action group, so... .500 meters per second left in the tank. 400 meters per second left in the tank. .300. We're gonna get escape. Okay, that's not bad. 236 meters per second. That should be good. All right. Let's warp out there. Lots of stuff transmitting back to Kerbin. Excellent. All right, so that guy is in range to hit Kerbin directly, it looks like. Where it may need a relay is if it's out of line of sight. And hopefully it'll be able to bounce off that satellite and then get to Kerbin. Alright, now hopefully I can lower my periapsis enough with the gas, the fuel I have left, to land. Oh boy, it is going to be cutting it close. Can I get down to 30,000 meters? Yes. Okay. That does not leave a lot of margin for error. Whoo boy. Okay. But I think I have enough energy in that rocket that I can expand this fuel tank a little bit. So I can bring some extra weight, some extra mass is the right word to use there. Now, the next question mark is going to be re-entry. Is this thing going to be stable on re-entry? Alright, let's go ahead and warp out here. warp to that point. Okay. Here goes. All right, let's finish warping until we hit the atmosphere. I'm gonna keep the stability assist on, and then we're gonna see how this goes. I would not be surprised if we lost those solar panels. So they are kind of hanging out in the plasma stream, so... we'll see. So far, so good. Alright, we are passing out of... or we're slowing down enough that we're no longer getting the heating effects. Once we're slow enough, I'm going to go ahead and turn off the stability assist, and I want to see what happens. And slow enough is somewhere around 300 meters per second. See, now I can deploy the chutes if I need to. Turn the stability assist off, and it's stable. It kind of wants to flip around, but it's heavy enough on the bottom that it's keeping it oriented correctly. Alright, so let's go ahead and get this thing to the ground. So that was our first, like, I don't know about our first, but that was a very clean mission, except for a little bit of a close call on the fuel. But I think if we throw just a little bit extra in there, it'll prevent that from happening in the future. But I think we have a solid vehicle. So let's go ahead and recover it, and let's see what we got. Should be probably around 400-ish. For 900 or 397 science earned. Good. So that will get us what? Propulsion systems. Orbital maneuvering engine. Spark liquid fuel engine. Ant liquid fuel engine. Some external tanks. These are basically little tiny tanks. Let's see, do I want to do any of this? Extensible crew tube? No. Radial probe. Probodyne Octo 2. Let's see, electronics would get us this Communitron. 61 gigameters, that's pretty nice. The seismic accelerometer. And the relay antenna. Communitron ground HG48. I guess that is an extra ground-based transmitter. Grand Slam passive seismometer. That gets us more science. So I'm going to go ahead and grab that. Do I need recycling? This is for life support stuff. Do I need storage tech? We are eventually going to need storage tech. Let's see. Propulsion systems. That gets me to precision propulsion. We are probably going to want these options. So I'm going to go ahead and grab this one just because I have a little extra. So go ahead and grab that. There we go. Alright, so I think that's probably good for an episode today. A successful flight to the moon. We'll probably set up one of those little ground science bases on Minmus next. And we'll actually, I'm probably going to bring a second cargo container for the extra experiments that we have. Yeah, that should work. Alright, so for now, we'll end it here. So I hope you guys enjoyed it. Thanks for watching. Go ahead, like, subscribe, and comment. And I will see you next time.